All right, so we need to find the horizontal asymptotes. Now in the lesson, we said that with the horizontal asymptotes, it basically is the end behavior of our function. Now the end behavior is what happens at the ends of the graphs. Now, once we go over limits in calculus, the reason why the horizontal asymptote does what it does makes a little bit more sense. But as for now, I said you just need to remember three things. If the degree on top is larger, there is no horizontal asymptote. You have to divide to find the slant asymptote. If the degrees are the same, the horizontal asymptote is you divide the leading terms. And then if the degrees on the degree on the bottom is larger, then it's y equals 0. So if you notice on number 1, the degrees are the same, so you divide the leading terms. So x over 3x, you get 1/3. So that's my horizontal asymptote for number 1. For number 2, I have x over x squared. Well, the degree on the bottom is larger, and so therefore it's going to be y equals 0. On number 3, I know it's a little bit more abstract because everything hasn't been foiled out, but this is x. This is technically, if I multiply this out, right, this is x plus 3 times x plus 3. Well, that's going to give me an x squared. Well, x over x squared, it's going to be larger on the bottom, and so that's why it's going to be y equals 0. On number 4, if you notice, the degree on top is larger. So it's going to be a slant or oblique asymptote. And so for us to find that, we have to divide our polynomials. And you're going to have to use long division to be able to divide it. Placeholder for the constant. So x squared goes into x cubed, x times, multiply, 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 then subtract. 0, 3x squared, 3x, and then 0. So once again, x squared goes into 3x squared, now plus 3 times. Now this is all I need to worry about. I know anything else that I get is going to be the remainder. So my oblique asymptote or the slant asymptote, the equation is going to be y equals x plus 3. Now visually, that's a line, right? It starts at 3, rise over run. So it's going to be a line. So that instead of it being a horizontal asymptote, it's going to be at a slant. And so that's what the asymptote's going to look like. For number 6, it says identify the domain. So the domain, we have to set the bottom equal to 0. So x squared plus x minus 12. That factors into x plus 4 and x minus 3. So x equals negative 4 and positive 3. Everything else can exist, so that's why it's going to be from negative infinity to negative 4, union from negative 4 to 3, union from 3 to infinity. The vertical asymptotes, there's nothing that would cancel out in the numerator, so they're both going to be vertical asymptotes. There aren't any holes. Horizontal asymptotes, because the degree on the bottom is larger, it's going to be y equals 0. Alright, next. It says find the x and y intercepts of the graph, if any exist, test for symmetry. So the x and y intercepts, remember you have to plug for the x-intercept, you plug in y equals 0. For the y-intercept, you plug in x equals 0. So for the x-intercept, x squared equals 4, x equals plus or minus 2. I can't do that, so I have to write them as points, because an x-intercept represents a point. And in this instance, you get y squared equals 4. So y equals plus or minus 2. So it'll be 0, 2, and 0, negative 2. Testing for symmetry, that's where you plug in the negative. So if it's symmetric over the x-axis, then you're going to plug in a negative for the y. And I have to check, are they the same? The answer is yes. Now if you do the same thing over the y-axis, you're going to get the same thing. You replace the x, and it's going to be the same. And then you have the origin, and that's where you do both, and if you do both, it's going to be yes. So it's yes, yes, yes. It says write the set using interval notation. So I have x is greater than 2, so here's 2, and then I have open circle at negative 1, and equals. So close circle at negative 1 and close circle at positive 1. So interval notation, that's going to be negative 1, union, 1, union, 2 to infinity. And then number 9, this is an inequality. So remember, you're going to do the sign charts. So you're going to subtract the 5x, subtract the 9, x squared minus x minus 2 is greater than or equal to 0. The zeros are going to be so 2 and negative 1. So negative 1 and positive 2. Now you have to test each of the regions. It's equal to, so it's closed circle. So testing each of the regions, right? If I plug in a negative 2, you get negative, negative, which is a positive. If I plug in 0, you get a negative and a positive. If I plug in 3, you get positive, positive. And so it's asking for values greater than or equal to 0. Values that are greater than or equal to 0 are positive. So that's going to be my solution set. And I'll let you guys write the rest in interval notation.